All right. Well, just as a quick follow on to the sort we implemented last time, I thought I would show the solution here. One thing of note is that we've got an allocator now, something I've been playing with. So in the standard library, we have the beginnings of a really basic arena allocator. Um, we have the ability to push onto an arena. We can push something of type T. We can push just some raw bytes and get back a pointer, which is what we're doing for this file load function, and then we can free everything. So, it's just in its beginnings, but I thought this was a neat way to show off context functions. So I say let context alloc equals allocator init default, and then I call files read to string. Now, if I did not create this allocator, then let's move this. Equal, and maybe I'll just do this. And then this can just be, open to the standard library. Maybe I'll just do it this way. Okay, anyway, we see failed to find context parameter alloc. No context variables of type allocator are in scope. This is because files read to string, go to core, takes an allocator, and it takes it as a context parameter, which means you don't have to type it if you've got one in scope. It's just pure like elision from a syntactic perspective. It's still a completely static parameter. So this is completely stolen from Scala's implicits. Oh, it works a little bit differently. So go back to day one. I already thought that was really neat. And what files read to string does, so what files read to string does is it uses a bunch of Unix functions. Basically, it opens up a file, figures out how big it is, reads the whole thing, and then returns a string. What's really neat though is one of the very first things I did when I started K1, once I got pretty far, was write this standard library, and I wrote it in Zig, and I compiled it to LVMIR, and I merged that together with my code so that I had access to some of these built-in functions. And one of the first ones I did was read file to string because I was doing additive code. And then what I did is I didn't really like having the entire Zig like dependency just for that. So I was like, you know what, let me just write it in C because this will work fine. So I wrote it in C. So I've been using this read file to string, and it's also how I implemented crash for the longest time because I didn't really have a proper never type. I didn't have the ability to do any of this stuff, and I couldn't implement this in K1. So I implemented it here and then linked into it. I also had these custom allocs and frees. The idea was to, this would go through the allocator. And I think I still might do something more global than using the context params for allocator, because I don't think that you want to annotate every single function in your code base as requiring an allocator. I think I'd like that to be the more manual approach, where if you don't, then you kind of get a thread-based global one for free. But anyway, now I don't need this. I don't need this. So we can actually stop linking with this. We're no longer calling the C version. So here's the C version. And, it's kind of tricky actually to convert the path to a C string. I actually kind of like the K1 version better. I think, in a way, the C is better in K1 than C because we can just call path to C string here. This really should take an allocator as well. There doesn't. There's still, most of the standard library is just calling malloc and free. And this is sort of just an example to get started and show off that feature and kind of how it might be used. So anyway, we return our string after freeing the temporary C string. And we've got our input. And then we let star. So what let star does is it looks at the right-hand side and it says, okay, whatever type you put there, I'm going to give you back a pointer to that type. So it's kind of like doing that, like Java knew, right? You get back a reference to the thing on your right-hand side, and you get back a stack reference. So this is like how you do a reference or some mutable data that's just on your stack. If you wanted something on the heap, then what you would actually do is, well, it should be implicit. So something will just implicitly take an allocator, and I'll probably do like some nice helpers. But right now I have alloc. I could get the temp arena, and then I could push and then take that, and then that would also return the same thing. Maybe we'll try that. Next. But anyway, so we allocate left and right. So this puzzle is we have to sort the left and the right. All the digits appear on the left and all the digits appear on the right. And then compare, take the min of each, find their difference. And then take the min of each that remains, and then sum up all of those differences. So what we do is we say for line in input.split by char, new line, split by char, string.k1, split by char is implemented in k1 as well. And there's a note here that I could actually do this sort of completely allocation free and just by moving pointers, indexes around. But what it does is it builds up a little array, and it's just exactly what you'd expect with split by char. Could probably be written a lot better, but that's what we do. And notably, it returns an array of strings. So we get back an array of strings here, and we iterate over that. And so for each one, we're going to take, and I just can be asked to like parse differently. So we're doing 0 through 5, and we're doing 8 through 13 because my whole input looks like this. So we grab each of those, we call toInt on those strings, and then we force unwrap the optional. So if we didn't do this, then we would have optionals, and we would be trying to push optionals. Whoops. Oh, that's day one term. We'd be trying to push optionals. I think it's going to say could not infer all type args. No. Invalid parameter type passed to function push, expected I64, but got optional I64. So we have array of int, and we're trying to push an optional int in there. So we'll unwrap them. And then we'll call sort, which I went over last time. If we wanted to be immutable, we could do left equal left dot sorted. Well, we would have to assign, so we would do this. In a way, it's still just as mutable. It's the difference between a reassignment to an reassigning to a mutable local variable that points to immutable data versus just mutating the data in place and not having the thing be reassignable. But anyway, now some diffs. So for each row, so for L and left do, and then let R is right dot dereference the array, and then get it index is the index of this for loop. Yeah, so when you iterate using this for loop, you always get a sort of a magic variable called it index. And if you don't name, then the thing in left would be called it. So think about like for it in left, but we name it L here. So we have L and R. If L is greater than R, L minus R, else R minus L. We add that to our diffs, and then we print it out. So this runs, and this is our answer. And I'm not going to show my browser, but you better believe that that is the right answer. So actually, I am going to. One sec. Okay, your puzzle answer was 2,430,334. And that is indeed the answer that we output. So I know it's a pretty trivial program, but I think this represents quite a lot of work. There's still a ton of features, of course. This isn't really stretching the language. We didn't define any custom data types or do anything fancy with types, which is kind of a lot of what the language is about. It provides, facilities for abstraction and stuff. But I think this represents a ton of progress since last year. This went a whole lot smoother. It was kind of fun to write. Short of missing the sort thing, really didn't run into any problems or a couple of things that just pleasantly worked. So all in all, I'm really, really happy with this. Let's go for broke here and see if this works. Yeah, so we get the right answer. If we put our array on the arena instead. Now all that puts on the arena is the array struct. It doesn't put the array's actual data because array new does not take an allocator. Go into core namespace array. New does not take an allocator. It calls with capacity, which just calls malloc. But yeah, we'll get there. All right, yeah, thanks for watching. There's part 1.